Alright, Bismillahirrahmanirrahim. So hari ni kita tengok dua chapter, chapter 4 and chapter 5. For chapter number 1, 2 and 3 kita dah cover. Basically 1 and 2 kita dah cover on seminar 1 and 2. Chapter 3 I dah bagi dalam bentuk data cam, right? You belajar how to use Tableau, right? And then you tengok dalam video yang I post dalam I discuss tu, semua cover semua chapter number 3. Right, so hari ni kita tengok chapter number 4, which is very important chapter and very hard chapter lah, susah nak faham sikit. Chapter 3 dan chapter 4 ni senang nak faham, but chapter 5 is a bit hard. So kita akan try focus on more on chapter number 4 and 5 lah. Right, so kalau you tak faham chapter number 4, you tak boleh pergi chapter number 5 because they are interrelated lah. Okay, so now we move to definition of statistic. Right, so what is statistic all about? Statistic is a study dealing with the process of collecting, organizing, analyzing, interpreting and presenting information. Right, so basically it's a process of how information is known as data is being collected, organize the data. Once you collect the data, kita kena organize the data, and then once you already organize the data, we're going to analyze the data. It's all about statistics. And once you already got the result, then we need to interpret the result and present the result in a meaningful manner. Right, this is all about definition of statistics. So statistics can be divided into two types. Right, first is a descriptive statistics. Another one is inferential statistics. So there are dua type of statistics. Satu descriptive statistics. Another one is inferential statistics. So for chapter number 4 ni, kita tengok descriptive statistics. Right. For chapter number 5, kita akan tengok inferential statistics. So descriptive statistics is about how we describe the data, right? How we describe the data in terms of high, low value ataupun middle value, right? Itu kita describe data saja. Berapa banyak kemalangan jalan raya, kemalangan biasa tidak maut, apa semua kita describe saja. Right. Inferential statistics is about how to generalize the conclusion to the population. Right. Macam mana kita nak buat keputusan, nak generalize balik ke the whole population. Maksudnya kalau let's say kita collect a data dalam satu tempat saja, right, macam mana kita nak buat conclusion daripada data result yang kita dapat dari satu tempat tu kepada the whole population, keseluruhan area. Itu dinamakan inferential statistics. So descriptive statistics, kita akan tengok how to produce chart, graph, table, which is kita dah tengok dalam chapter number 3 before this. And numerical summaries means median, mode, variance and standard deviation. So mean adalah average lah, average. Median is a middle value, mode is a most frequent value. Variance and standard deviation is the dispersion of the data towards the mean. Right. For example, if you are studying on monthly pocket money obtained by 200 students selected from a total 1,500 students in the college. So we might want to find average monthly pocket money obtained by the student. So this is what we call as descriptive statistic. We want to find the average monthly pocket money. And then finding average monthly pocket money is an example of descriptive statistic lah. Actually. So basic statistical term. So before we go further, dalam you punya project nanti, you kena describe lah. Right? You ada data kan, you kena describe. What is population? What is sample? So we look into the detail, the statistical term yang you akan guna nanti dalam project report. Right? So population is a complete group, consists of individual, object, item or measurement to be taken for the purpose of the study or survey. So complete group, contoh, the whole let's say our population is all student in UiTM Perak. So all student is a complete group in the area of the study. So complete group of area in the study is a population lah. So let's say a company, kita nak buat survey dekat company A. So all staff in company A is a population. So the size of population may be small or large depending on the objective of the study lah. Some example of the population: all lecturers in UiTM Cawangan Melaka, all bachelor student in UiTM, all houses in Taman Demensi, all trees in park, and all age of all student in the class. So kalau you nampak dekat sini, the magic word is all. Disebut all, maksudnya semua member dalam group ataupun area under the study. Sekejap untuk test number 2 nanti. Right. So population dekat sini. So notation for population is capital N lah. Let's say N, capital N is 5,000 students in UiTM Perak, Tapah, sorry. So all students in UiTM Tapah, so total population will be 5,000. So capital N is 5,000. This is a notation for population. So kita tengok sample, right? Sample is a portion taken from a population for the purpose of a study. So for example, let's say you are studying knowledge, attitude and practice on dengue fever prevention at Perak Tengah District, right? So the total population or residents in Perak Tengah District might be capital N equal to 1,500, 150,000 residents, right? So untuk measure the whole population might be an issue lah. So issue apa? Issue satu, time consuming ataupun very hard to find the whole population, right? And then it will cost you a lot of money kan. So that's why in statistics there is another method called as sample. So we take a portion out of 150,000 population. So let's say small letter n, kita ambil let's say 100 saja daripada 150,000. So ini dinamakan sample. We take a portion from the whole population. So the symbol will be small letter n. Right, let's say I buat dalam bentuk grafik kan. Let's say this is the whole population, capital N equal to 5,000. So this is the all members in all student in UiTM Tapah, contoh kan. So nak measure semua member dalam UiTM Tapah ni might be impossible. So that's why we take a portion. So kita ambil satu saja. Let's say kita ambil kawasan ni. So kita ambil satu kawasan. This is N1. So sample number 1 consists of 100 student. So let's say kita ambil lagi satu sample. This is N2 consists of another 100 students. So kita ambil portion daripada population. So sample can be either randomly or non-randomly from a population. So I think nanti kita akan tengok sikit lah population sample, random sample or non-random sample. Ataupun maybe you pergi ke next subject MGT555, right, which is research methodology in detail lah kita akan tengok. For example, tadi kita ambil all lecturers in UiTM Cawangan Melaka. So sample we take only 60 lecturers in UiTM Cawangan Melaka, right? So kalau tengok lagi, let's say kita ambil all, the population is all bachelor student in UiTM. So kita ambil sample 80 bachelor student in UiTM Cawangan Melaka, right? For another example, all houses in Taman Demensi. So we only select double story terrace house in Taman Demensi. So that is a sample. We take a portion out of the whole population. So another term is sampling unit. Sampling unit is a unit of sample that has been selected from the population randomly on or non-randomly. For example, let's say we have the population. I draw the box kat sini, I illustrate kan. So this one kita ada uh, capital N equal to 5,000. So this is the whole all student in UiTM Tapa. I ambil benda yang kecil, example yang kecil ya. Right. So now, so dalam student UiTM Tapa ni we have 5,000. 1, 2, 3 until 5,000. So we want to select the portion. So we want to select N equal to 100 contoh. So this is what we call sample. So when we untuk select member menjadi dalam population ni, kita menggunakan sampling techniques lah, either random sampling technique or non-random sampling techniques. So let's say kita select person number 15, 22, 53 and so on lah. Kita select this one, masuk dalam sampel kita. So number 1 is student number 15 dalam population. Sample size number 2, sample number 2 will be 53. So sampling unit, right? Sampling unit ini dinamakan sampling unit. So student number 1 ini sampling unit number 1. Student number 2, sampling unit number 2 and so on lah, until we take all 100 students. Right? So setiap member dalam sampel ni kita panggil sampling unit. Right? Another term is sampling frame. Right? Sampling frame is a list of all members in the population. It's a list of all members in the population. So consists of their information, such as their name, their address, and so on lah. Right? So now, list of all members, maksudnya list of member in the population lah. So we need to have sampling frame ni dinamakan kita kena ambil this one number 1 kan, student number 1. Let's say dia punya nama, right? Dia punya ID, dia punya phone number, right? So it's a list kita ambil sampai 5,000 lah. So it's a list of all member in the population. So consists of their information. Sebab ini dinamakan sampling frame. Sebab apa kita ambil sampling frame? When you want to select a sample, a sampling unit, so let's say kita pick a number kan, kat sini kita bagi number dekat dia. So bila kita nak distribute questionnaire, kita kena tengok balik lah dia punya student ID, dia punya phone number, untuk senang kita contact that respondent, right? Itu tujuan sampling frame. So you need to remember, sampling frame is a list of all member in the population, consists of their information, right? Okay, alright. So example, a sampling frame dekat sini, list of all student names in a class, list of college name at UiTM campus Alo Gajah, list of companies registered at KLSE, which is Pusra Malaysia lah, right? So sampling frame is necessary when sample size are selected randomly lah. So kalau kita menggunakan random sampling techniques, so sampling frame is necessary. Kalau kita menggunakan non-random sampling techniques, sampling frame is not necessary lah, right? So next kita tengok another example, another term which is a random sample. So random sample, consider every member in the population has an equal chance or probability to be selected as sampling unit. For example, tadi example student kan, kita ambil student jugalah. This is a population, right? So we have population student number 1, student number 2, 3, 4, 5, 6, 7, 8 until 5,000, right? So random sample means that every member in a population has an equal chance to be selected as a sampling unit. So sampling, let's say n equal to 100. This is capital N equal to 5,000. So setiap satu member ni dia mempunyai equal probability 1/5,000. This is also 1/5,000. Every member has equal chance to be selected. There are no bias lah. Right. Another term is census. Census is banci lah. Pernah dengar kan? So a survey that takes all member in a defined population. So let's say we have 5,000 student in UiTM. We are not using sample. Kita tak menggunakan sample. Instead kita ambil semua member dalam UiTM Tapa. All student in UiTM Tapa. So the size will be 5,000 lah. This is a census. The best example of census is population census lah. Yang macam kementerian DOSM buat the Department of Statistics. So census is normally taken if the population to be studied is small. Kalau terlalu kecil kita ambil census lah, tak perlu ambil sampel. Right? Another term is sample survey. Sample survey is a survey takes only portion of the population. Maksudnya kalau kita nak buat knowledge, attitude and practice on dengue fever prevention, so dekat area Tapah Perak Tengah district. So Perak Tengah district we have 1,500 residents. So instead of taking all residents in Perak Tengah district, kita ambil sedikit kan, let's say 100 or 200 kan. So we distribute the survey, right, questionnaire. So this is what we call as sample survey lah. So the term pun sama, dia dah bagi hint kan kita ni, which is the sample survey. So pilot survey. Pilot survey is not a study about aircraft. So ada student yang dalam kelas dia kata pilot study dia faham, but in final exam dalam test, bila saya tanya apa itu pilot survey, dia kata a study on aircraft, which is wrong lah. So pilot survey is a survey that carry out before the actual survey. Before you go for actual survey, let's say capital N equal to 150,000 resident in Perak Tengah district. So you nak ambil sample N equal to 100 contoh kan. So before you go to the actual survey, you akan buat survey before the actual survey. Maksudnya you akan test the questionnaire. Let's say you develop a questionnaire, right? You develop a questionnaire, a set of question. So you akan test kepada orang selain daripada orang yang tinggal di kawasan Perak Tengah ni. You akan try tanya dekat kawasan orang dekat kawasan area Batang Padang contoh. Batang Padang. Instead of tanya dekat Perak Tengah district, you tanya dekat Batang Padang. Sebab you nak test whether your questionnaire ni orang boleh faham atau tak boleh faham. Sama juga konsep of goods. Bila you produce a good, you invent a new satu barang atau satu produk, before you start selling, you mesti kena test dulu dia punya barang tu okey ke tak okey. Right? The purpose of conducting pilot survey is to identify any problem that might arise before or during the actual survey. Also to pretest the relevant questionnaires, and hence questionnaire can be improved for the usage of the actual survey lah. Right? So now, tadi kita tengok the term statistics. Tadi kita tengok the definition of statistics, right? Statistics with S. Nampak tak? Statistic with S is a process is a process of how information is being collected, organized, analyzed, interpret, and present. So this is about statistics with S. So another term, ini kita tengok tadi kan, pada permulaan tadi slide, right? So now the new term which is statistic without S, right? Ada perbezaan, tak sama, right? Tak sama. Statistic without S is a summarized numerical value calculated from sample. So for example, let's say you are taking you are the population, all student in UiTM Tapa, let's say 5,000 student. So you take a sample, right? Let's say n equal to 100, right? So you measure dia punya monthly income of each student, monthly pocket money. Right? Let's say student ni dia ada student diploma, so dia ada monthly pocket money, right? So you know, you want to measure what is the average monthly pocket money. So you ambil daripada sini, let's say this is the symbol for average monthly pocket money. So let's say RM200, contoh kan. So the value X bar ni, mean ni, ini dipanggil statistic. The value of a summarized numerical summary from a sample. So mean, standard deviation, variance, right? So ini dinamakan statistic. So the symbol untuk mean is X bar, the symbol for standard deviation is S, the symbol for variance is S square. Ini bukan benda baru, you dah belajar sebelum ni kan. Even in SPM, kalau I tengok my niece kan, darjah 5 dah belajar mean standard deviation dah, right? So I think this is it should be very easy for you kan. So another term is parameter. Parameter, same as a statistic, is a summarized numerical value calculated from population. So when you calculate from a population, when you want to infer back to the population, right? So let's say daripada 5,000 ni you ambil beberapa sample, right? Let's say this is N2, so 100. This is N1. So you calculate X bar 2 equal to berapa ratus kan? So you akan ambil daripada mean of the mean, sample mean. Mu equal to X bar 1 plus X bar 2, right? Divide by 2. So this is the formula lah. Tapi I just want to show it to you. The symbol for mean is mu. The symbol for standard deviation is sigma. Symbol for variance is sigma square. So the symbol is different lah. It's represent this symbol is represent mean for the population. This symbol represent mean for sample. I hope you understand. Ada soalan tak setakat ni? Soalan? Right. So now this is the table shows the difference between parameter and statistic lah. So number of cases tadi kita nampak tak? I tunjuk capital N, small letter n to show the difference between population and sample. From now on we will say this is a parameter, this is a statistic, right? So I hope you can differentiate parameter and statistic. So this is the mean for population. This is a parameter of mean. This is a mean for sample. This is a statistic mean, right? So kalau you baca paper ke, you baca report kan, dia kata parameter mean. So we know that parameter mean is mu lah. This is calculated from population. Disebut statistic mean. So this is a X bar. Kita tahu dah. Boleh baca paper, you boleh faham. Right? So another term which is variable and data. So I think this one you should know already. So variable is a characteristic of interest, which about each individual element of the population is sample. So let's say you are studying knowledge, attitude and practice on dengue fever prevention at Perak Tengah District. So you nak buat research tu kan. So you are interested to know some of the demographic characteristics such as age of the respondent, dia punya ethnicity, dia punya knowledge, dia punya income, right? So age, ethnicity, gender, income, right? So this is what we call as a variable. The variable of interest. Maksudnya something that we want to know from the respondent. So the value inside the variable, let's say 72, 55, 42, 31, 32, 31, and so on. This is Malay, Chinese, Indian, right? And gender, Malay, male, female, income, 3,000, 4,000, 5,000, and so on. So the value inside this variable, this is what we call as data. This is variable. This is data. Right. In fact, dalam slide first I dah sebut benda ni kan. Right. So data is the value of measurement observed or observation collected for the variable. Okay. So since we are looking into variable, right? So variable can be divided into two types. So I letak sini. So variable can be divided into two types. Variable. You need to write down. Variable can be divided into two types. So dalam buku I don't think it has. I think benda ni I dah sebut dah sebelum ni. Dalam chapter 1. Saya dah pernah sebut kan? Right? I pernah buat benda ni kan dulu. So I tak pergi detail lah. I think seminar number 1 I dah pernah sebut. Variable can be either two types. First is qualitative. Another one is quantitative. Right? So qualitative variable is a categorical variable. This is a numerical variable. Categorical variable such as male, female, ethnicity, Malay, Chinese, Indian, right? Numerical is such as height, 160 centimeter, 172 centimeter, weight is 42 kilogram, 42.2 kilogram, and so on lah. So under quantitative, we have two sub division to sub types, which is discrete quantitative. Another one is continuous quantitative. I think this one I already bagi lecture dulu yang masa mula-mula chapter number 1 first lecture I ada sebut berkenaan dengan berkenaan dengan variable qualitative and quantitative. So just a quick review saja. Discrete is the variable that does not have a decimal point. Right? We cannot measure the discrete, the value in discrete, but we can count based on count. Right? Contoh, number of children, number of family, number of car. Right? So dia tak ada decimal point kan? Number of children 1, 2, 3, 4, 5. Number of car 1, 2, 3. Right? Kalau 3 tu extraordinary lah. Banyak dah kan? So continuous variable, continuous quantitative variable is a variable that we can measure using instrument tools such as pembaris ke, dia punya penimbang ke kan. Dia ada scale untuk measurement dia tu. Right? Let's say height, we have in centimeter, meter and so on, kilometer. berat, gram, miligram, kilogram and so on, right, tan apa semua. So ini dinamakan continuous lah, and then it can have a decimal point lah, 14.2 and so on lah. So we know that this is a quantitative and qualitative. Quantitative is a categorical variable. Qualitative is qualitative categorical variable. Quantitative is numerical variable. So under the variable ni, we have measurement scale. So we have two type of measurement scale for qualitative, which is nominal. Another one is ordinal. For discrete and continuous, we have interval and ratio, right? Ratio. So this is more informative, and this is less informative. Sebab apa less informative? Because let's say you categorize male and female, so we only have male and female. And let's say you categorize the income less than 1,000, more 1,000 to 2,000, right? So kita tak tahu the exact value. Kalau kita letak ratio, maksudnya kita tahu the exact value lah. Interval and ratio is a quantitative. So the difference is whether 0 is a true value or not true value. So if you cannot remember, please refer to my first seminar. So this is our objective of chapter number 4. Right, we want to learn about mean, median and mode. Tapi kita akan focus more on sample lah. Instead of population, kita focus on sample. Right, so mean is the average, median is the middle point of the arranged data, mode is the most frequent value, right? So this is the mean. Mean is the arithmetic. The arithmetic mean is commonly known as average of the data value lah. It is the sum of all value of data observation divided by the number of observation. Right? Let's say you have 5 data, 5, 2, 3, 4, 5. Right? So you nak cari mean. Apa ni? Nak cari mean. So you kena tambah lah 5 tambah 2 tambah 3 tambah 4 tambah 5 bahagi dengan berapa value? 1, 2, 3, 4, 5. So you will get mean lah. So mean can be calculated from ungrouped data and group data lah. So ungrouped data is this one lah, data yang tak ungroup. Group data, data dalam bentuk frequency table. So let's say 5 to 10, we have frequency. This is a class, there's 10. 11 to 15, contoh ni we have 15. So this is a group data. Right, median. So kita tengok simbol lah, simbol yang saya bagi dekat sini. This is mean is X bar. This is a sample statistics. Right. So median is a middle value from the arranged data. Right, middle value from the arranged data in ascending order. The symbol for median is X tilde. Right, X with a tilde. Tilde ni macam cacing tu kan. So let's say kita ada data tadi 5, 2, 4, 3, 5 contoh kan. So to find the median value, so we need to arrange data of 2, 3, 4, 5, 5. So middle value of the arranged data, this one lah. Right, so this is your median, right? So interpretation of median can be is 50% of the data, the median is the 50% of the total observation having value less than median value. So 50% of the data having value less than median value, while another 50% of the data having value more than median value. So that is a interpretation of median, right? So mode is, the symbol for mode is X hat, right? X with the hat, right? Dia ada hat kat sini. So the most frequent value to occur is a mode lah. So tadi kita letak 5, 2, 3, 4, 5 kan. The most frequent value kita ada 2 kali muncul 5. So mode is 5. So I hope you don't have any confusion or problem here because this is very basic, right? Even standard 5 pun dah belajar benda ni kan. Okay, so now, so Excel function to find mean, median and mode. So to find mean, the Excel function is average data range lah. And median is median data range. Mode single data range. This is for single mode lah. So now, this is what we call as all the value here. The lies, kalau kita tengok dalam buku statistik kan, kita kata measure of central tendency. Right, so measure of central tendency ada 3 benda. Mean, median and mode. So another term yang kita akan tengok adalah measure or dispersion or variation. So kita akan tengok range, variance, standard deviation. So why we need standard deviation or why we need variance? So for example, let's say I collect a data dekat 2 playground. Let's say this is a playground 1. I collect 10 data, 10 children. I collect dia punya age. Right, so I dapat macam ni lah. So the mean here, the mean age will be X equal to 5 years old, for example. So I pergi ke playground 2, I collect 10 student, 10 children. So I dapat dia punya mean age. Let's say mean age dekat sini and this one. X bar also equal to 5. Can we say these two sample are equal? Of course, we have a lack of information dekat sini lah. Right? Sebab kita perlukan standard deviation. So standard deviation, let's say for playground number 1, standard deviation will be, let's say this one should be 3. Right? Ataupun 2 lah. Sekejap, I letak 2. 3 pun boleh lah 3. Okay lah. 3. The standard deviation for group number 2 ni, let's say I dapat 1 saja. So of course, kalau kita tengok dekat sini, the 3 maksudnya, the observation dekat sini sangat mencapah. Right? Dia disperse. Right? So ada yang umur kurang setahun ataupun lebih daripada 8 tahun. Right? So dia punya observation ni besar. Kalau kita tengok yang nombor 2 ni, observation dia sangat kecil. Ada yang 4 tahun minimum, 6 tahun maksimum. Contoh, right? Paling banyak 6 tahun ataupun 4 tahun. So ada perbezaan dari segi distribution dekat sini lah. So that's why we need to have to learn about the standard deviation. So range dekat sini adalah the maximum value minus minimum value lah. Kita akan dapat range of the data. Variance and standard deviation. Variance is S square. Standard deviation is S sahaja. So we just take a square root of S square, should be S lah. Maksudnya we take a square root of variance, kita akan dapat standard deviation. Right? Tadi ada cerita sedikit berkenaan standard deviation. So the Excel function to find range is maximum data minus minimum data. Population variance dot var dot p, yang kita ambil data. Sample variance var dot s, kita ambil data. Population standard deviation stdev dot p data, stdev dot s data. So and then for z score, standardized, X mean standard deviation lah. Right. So next kita akan tengok coefficient of variation before we go to the example demonstration kan. So this is the last slide kan. Okay. So coefficient of variation. Macam tadi ada dua benda, right? Ada dua distribution. So which distribution is more consistent? Nah, kita nak tengok which distribution is more consistent. Ataupun let's say kita buat dua company, kita measure dua company kan. Mana dia? Company A and company B. Right? So kita nak measure the amount of salary given to company A for the employee. Right? So kita dapat macam ni. For company B, let's say kita dapat lebih kecil sikit. Right? So we know the mean for this one is 2000 contoh. Right? The mean for this one also 2000. Right? 2000. So kita tengok the standard deviation. The standard deviation for number 1 will be 500. Standard deviation for number 2 will be 200 contoh. So coefficient of variation dia bagi tahu kat kita, we want to compare the dispersion or spread or variability of two or more data distribution, then the appropriate measure known as coefficient of variation. So coefficient of variation is a relative measure of dispersion. So we want to know from this one which one is more consistent. Right? Consistent dalam pemberian gaji lah. Right? So let's say the formula will be S divided by mean. Right? Standard deviation divided by mean multiplied with 100%. So the coefficient of variation yang kecil adalah memberi petanda dia adalah lebih konsisten. Contoh ada kat sini. If the coefficient of variation distribution A is greater than coefficient of variation distribution B, then we can say that distribution A is more dispersed. Right? Ataupun we can say distribution B is more consistent compared to distribution A. So the coefficient of variation is useful when comparing dispersion of two or more data distribution. Right? So now let's look at the demonstration. Ada soalan tak before we go to the demonstration? Soalan?
Tak ada, doktor.
Ada, doktor? Ada?
Tak ada. Okay. So.
Alright. So now kita tengok first data set which is purchase order transaction. Semua dah buka dataset yang sama? Sudah? So kita tengok purchase order transaction. So now to find mean of order amount. So order amount dekat sini lah. So we have basically berapa? Ini yang kita buat dulu kan? Kita cari number of minimum quantity, let's say number of order. Number of order order amount. So number of order amount kita nak cari macam mana? Count ni sampai habis kan? So kita ada 107 data. Right? So to find mean, this one I think you already terror already kan? To find mean of order amount, we just put average, right? And from this one to this one. So kita akan tutup kurungan dapat average lah. Right? So median of order amount. So median, just type median from this one to this one. Right? Tutup kurungan. Right? Boleh? Kau cepat sangat? Right? Median, you just put median lah. Right? So mode, M-O-D. Kalau you tekan mode dekat sini, you type mode, nampak tak ada drop down menu? Right? Dia ada mode.multi, mode.single, and then last is mode. Kita akan menggunakan mode.single. So dia kata dia akan bagi description kat sini kalau you tengok you punya sendiri. Return the most frequent occurring or repetitive value in array or range of data. So kita akan menggunakan mode.single. Right, so kita cari this one and tutup kurungan, kita akan dapat this one. Right, so very simple. Right, before I hope you can understand this one, very simple. So range is the maximum value minus minimum value. Maximum value just menggunakan max tutup kurungan minus minimum value. Minimum min sama juga, kita ambil sampai ke bawah tutup kurungan. Right, so but this one is first part lah yang nak tunjuk dekat sini. And another one yang nak tunjuk menggunakan data analysis toolpad. So variance. So since kita menggunakan sample, so kita just type variance dot. Kalau kita tekan variance dot, nampak tak ada drop menu? Kita akan pilih variance dot s, which is estimate variance based on sample, ignore logical value and text in variable lah. So this one kita select sampai bawah, tutup. Right, so variance besar sikit lah variable lah. So standard deviation, either you can take square root of the variance, right, square root of the variance, ataupun you boleh type stdev dot s. Right, so standard deviation sample should be this one. Tutup kurungan. Right, okay, boleh faham? Very simple. I am hoping that you are using Microsoft Excel, bukan Open Office. Sebab I nak tunjuk my objective dekat sini. I bukan nak tunjuk the values. This is part of the syllabus. But normally kita jarang pakai this one lah, untuk get the unless we are doing the dashboard kan, kita akan menggunakan this value lah. For statistics, selalunya kita akan jarang pakai ini. So now, kalau you pergi ke data tab, kita ada home, insert, draw, page layout, formula, data. You pergi ke data, right? Semua pergi ke data? Boleh tak? Tolong, this is very crucial step. Dah? Sudah ke?
Dah.
Right. So you pergi ke hujung sekali, you akan nampak data analysis. Ada tak data analysis tool? You ada tak? You nampak section ya, get transform data, queries connection, data type, sort and filter, data tool, forecast, outline. Selepas outline dia ada analysis. Semua ada benda ni? Kalau tak ada, angkat tangan. Tak ada. Alright, so I will show you how to get this one. So first, you need to go to file. Pergi ke file. Right? And then you go to option. Sekali lagi, file, option. Sudah?
Ya, doktor.
Sudah?
Dah.
Alright. So next you akan nampak this one kan, this box kan, Excel option ni. You tekan add-ins.
Okay.
Okay. Now sekejap So kalau you dah install, you akan nampak active application add-in kat sini. Analysis toolpad. You ada tak analysis toolpad kat sini?
Analysis to pack. Lepas tu ada bawah lagi satu dia macam apa? VBA.
Oh, yang ni yang ada. Yang atas ni tak ada.
Yang atas tu
Saya ada.
saya alamak dia yang inactive application admins.
Okey. So adalah
Tu
dia adalah inactive kan?
ha
Ini dekat bawah kan dia ada VBA dengan toolpack saja kan. So now you
betul.
go to Excel add-ins dekat sini, manage Excel add-ins
Sekejap mana tadi?
dekat bawah ni. Dia ada
Okey.
Excel add-ins kan. Okey, you
betul.
tekan go.
Okey.
So dekat sini you by right you punya mesti kosong semua ni lah. Right?
Betul.
So you tekan analysis toolpack. You check
Analysis tu sahaja.
sahaja, jangan VBA tak payahlah.
Okey.
And then you tekan OK lah. Semua boleh ikut. So bila you tekan OK,
Boleh.
then
Ada.
you pergi ke data, you akan nampak hujung sini ada data analysis.
Analysis.
Kalau you tak nampak, contoh sepatutnya kena nampak lah kalau macam sekejap I tukar screen yang kecil, still nampak juga. Kalau you tak nampak, maybe ada button untuk tengok hujung sekali lah.
So far tapi dah okey dah.
Dah okey kan? So now,
Thank you dah.
semua dah dapat ya? So, kita ada lagi 1 jam, I nak masuk chapter number 5. Right, very crucial. Chapter number 5 tu susah So, now, you tekan data analysis dekat sini. You akan dapat this box. Right. So, this box. So, kita cari descriptive statistic. Ada tak descriptive? Descriptive statistics. Right. And then you tekan OK. So, bila you tekan OK, dia akan keluar this dialog box lah. Right. So, dia ada 2 section dekat sini. Input and output. Right. So, dekat input, kita ada input range, group by, label in first row. So, now, kita tekan dekat sini. Kita tekan kat sini, the arrow atas ni, up arrow. So, kita select from number 1 ni, order amount ni sampai habis lah. So, order amount. Biasa kita tengok order amount lah. The first one until habis. So, now you notice tak, step yang I buat ni, dia different kalau you select from order amount ni. Now, I select daripada data. First data of order amount sampai akhir data order amount. So, I tekan this one balik. So, group by column, sebab kita ambil by column. Kalau kita ambil by row, kita ambil by column row lah. Tapi this one by column lah. Right? And then label in first row. Since kita select tadi daripada G4 tak termasuk label. Right? G4 tak termasuk label. So, kita uncheck this one. Right? Kalau kita ambil this one daripada order amount to the last one, right? Since label dah masuk, so kita akan check label in first row. Faham tak? So sekarang kita ambil yang basic lah daripada first data hampir sampai hujung data lah. Label in first row kita uncheck. So this is crucial lah, you kena tengok benda ni betul-betul. So now dah buat tu, kita akan tengok second section, kita ada output option. Output option, either we have output range, new worksheet ply, new workbook. New workbook dia akan create a new Excel file lah. New worksheet dia akan letak sheet baru. Since kita nak tengok dekat sini juga, I akan tekan output range. Output range dekat sini, I letak kat mana I nak letak. Let's say I letak kat sini. This one patutnya sebelum ni I dah buat tapi tak pada habis kan. So I letak dekat L105. L105. Right, and then dekat situ, dekat bawah pada tu, kita ada summary statistics. We check summary statistic. We have confidence interval for mean, confidence level for mean. We check this one and make sure 95%. 95%. Tapi kalau you guna selain daripada Microsoft Excel, you tak ada benda ni lah, right? Ini Microsoft Excel saja. And then you click OK lah. Semua dah check this one. K, largest, K, smallest, tak payah lah. Ya.
Sorry. Saya tak dapat catch up. Tadi kan yang doktor letak dekat L105 tu kan?
Ya.
Lepas tu apa saya terlambat catch up sikit.
Tekan summary statistic. Kita check summary statistic ni. So by default dia macam ni. So you check summary statistic and check confidence level for me.
Okay.
Alright, and then you click OK lah.
Alright.
So you akan nampak dekat sini the value yang dia bagi.
Ada. Thank you.
So kita nampak dekat sini the mean dia dah calculate kat kita. The median also calculated. Standard error, the information, additional information. Standard error pun dia dah calculate. Standard error is standard deviation divide by, sorry, I lupa dah. Standard deviation divide by total n square root. So variance in the divide by square root of n. Ataupun this one should be s divided by square root of n. So this is a standard error, right? So mode, kita ada mode tak kat sini? Mode sepatutnya dia dah bagilah benda yang sama. And then dia bagi dekat kita standard deviation, variance, curtosis, skewness, range, minimum, maximum, sum, count, semua dia bagi kita. So we no need to calculate one by one lah. Okay? Alright. Boleh faham?
Okay, boleh.
Alright.
Tetapi nak tanya,
Yeah.
yang inilah yang descriptive ni yang buat dalam assignment group tu kan?
Assignment group.
Yang maknanya yang inilah kan, yang data set tu yang kan kita orang dah bagi.
Part of it, satu. Part pertama lah. Yang kita ada satu lagi inferential kan, yang kita nak tengok sekejap lagi. So dalam
contoh sebab data tu macam kita orang vacancy, maknanya kita boleh choose lah apa yang kita nak and then keluarkan yang tadi tu lah, macam tu.
Betul. Keluarkan mean, mode, standard
Contoh
deviation.
sebab dia ada banyak tau, macam sorry doktor tanya sebab saya nak lemah sikit kan. Contoh macam dia ada vacancy, education level based on state. So kita boleh pilih lah apa yang kita nak and then kita just elaborate macam tu.
Ya, betul. Bukan semua benda yang dalam data tu you akan elaborate. You akan set objektif lah. Let's say you nak focus on vacancy dekat mana kan. So then
Okay, kita faham.
Okay.
Alright, thank you doktor.
Alright. So next kita ada stock closing stock price. So now remember tadi coefficient of variation, right? Coefficient of variation kita tengok dalam slide ni kan. Slide. Coefficient of variation, standard deviation divided by mean, multiply with 100%. So this one I give to you, you buat sendiri sebab kita dah terlebih sikit daripada setengah jam tu. You cari mean and standard deviation and you cari coefficient of variation. And you determine which bank has more consistent stock price. Okay? So I leave it to you. Nanti kalau you tak faham boleh tanya next dalam WhatsApp group ke ataupun I discuss. Alright. So I think kita akan rehat sekejap sebelum kita pergi ke chapter number 5. Chapter number 5 which is mana? I punya slide ni komputer dah slow sangat lah. Which is statistical inference. Chapter number 5. Alright, so kita rehat 5 minit. Okay? Okay, doktor. Okay. Alright. For chapter number 5, which is inferential, statistical inference or inferential statistics. Right. So let's look at the introduction first. So what is inferential statistics? So inferential statistics refers to drawing conclusion about some characteristic of population statistically based on a random sample from that population. So if you are using a random sampling techniques, then you can draw a inferential or conclusion to the population. So inferential statistics utilize sample data to make estimation, prediction or decision about the population. Macam tadi saya cakap lah. For example, tadi kita dah collect data. We have number of population kita nak all students in UiTM Tapah, right? 5,000 students. So there are a lot of students here. So we take first sample N1 equal to 100. So we take another sample N2 equal to 100. So let's say kita ambil satu sample N3 equal to 100. So we have 3 sample. Each sample have sample size dia lah 100, 100 and 100. So total sample size is 300. So we are measuring the monthly pocket money. So we get X2 equal to 200 contoh. X3 equal to 250. X1 kita dapat, let's say this one 300. So we want to infer back to the population. Kita nak kata all student in UiTM Tapah having average pocket money berapa ringgit. So kita akan cari mu equal to 200 plus 300 plus 250 divide by 3. So kita akan dapat the amount. So this is the average of mean pocket money for student, all student in UiTM Tapah. So statistical inference incorporate estimation of population parameter and hypothesis testing. So dia akan ada hypothesis testing kat sini lah. Instead of kita letak mean saja, kita akan ada hypothesis testing. So hypothesis testing is a procedure based on sample evidence and probability theory to determine whether the hypothesis is the reasonable statement. So this one you need to pay attention, right? Because it's a bit confusing and you need to understand properly untuk project you nantilah. So hypothesis testing applied to determine whether the sample does or does not support the statement concern the population. So for example, hypothesis can be either two, right? It should be two statement lah. This is what we call null hypothesis, and another one is alternative hypothesis. So this is what we call null hypothesis, and this is what we call alternative hypothesis. Right? So nanti kita tengok example dia. Right? So step in the hypothesis testing. So first we need to formulate the test formulate the hypothesis testing to test by stating null hypothesis and alternative hypothesis. Contoh null hypothesis, let's say we want to know, is there any difference between on mean pocket money between girl and boy. So kita punya objektif kita to determine the difference of mean monthly pocket money between boys and girls. Right, kita nak tengok sama ada perbezaan tak mean pocket money ni di antara student lelaki and student perempuan. So the null hypothesis will be there is no difference on mean pocket money between boys and girl. Right? The alternative hypothesis, there is a difference on mean monthly pocket money between girls and boy. Right. So kalau kita tengok dekat sini, the alternative hypothesis, the statement is no different. The alternative hypothesis, there is a difference. So benda yang sama. We want to find the objective study kita. We want to determine the difference of monthly pocket money between male and female, boy and girls. Right. So the null hypothesis, there is no difference. Alternative hypothesis, there is a difference. So ini adalah statement hypothesis. Right. You remember, null hypothesis always no different, no relationship, no significant, no everything no lah. So alternative hypothesis H1 ataupun HA, there is a difference, there is a relationship, there is a correlation, there is a association. So dia terbalik dekat situ. Right? The second step, once you already identify state the hypothesis statement, so we need to select a significant level. Significant level is alpha. Alpha is selalunya kita letak 0.05 ataupun 0.01. So untuk understand significant level ni, kita akan tengok the confusion matrix. This is what we call confusion matrix. So this is actual, this is predict. So let's say kita kata dekat sini yes, no, yes, no. Contoh, right? Kalau kita punya result of hypothesis ni, kita predict dia population tu yes. Tapi dalam actual population, dia memang yes. Maksudnya dia true. Ataupun kita letak instead of yes, true lah, senang. This is true, false, true, false. Senang nak faham kan? So, kalau dalam prediction, kita kata itu betul. Tapi dalam sebenar, data sebenar, kita dapati benda tu betul. Maksudnya, we are make correct decision. Betul? Kalau dalam prediction, kita kata benda tu betul, tapi dalam actualnya, benda tu salah. So, this is what we call incorrect decision lah. Incorrect decision. But this one, kita dalam statistik, kita panggil type 1 error. Type 1 error. So, dalam prediction, kalau kita kata benda tu salah, tapi sebenarnya benda tu betul, kita make a incorrect decision. This is what we call as type 2 error. Kalau benda tu salah, kita kata kita predict salah, tapi sebenarnya memang salah. This is a correct decision. So, dalam type 1 error is also known as alpha, right? The symbol is alpha. So, kita dalam untuk hypothesis, kita nak minimumkan kesalahan, right? So, selalunya kita akan letak set 5% of mistake lah. So, that's why kita akan ambil level of significance 0.05 ataupun 5% to indicate that the result that we produce from the hypothesis testing ni, hypothesis yang segment ni, result yang kita dapat ni, kita reserve 5% of making a mistake. 95% we are confident of our result. Faham tak apa yang cakap? Boleh faham ah? So, type 1 error ni kita minimizekan sebagai 5%. Maksudnya kita reserve all of our analysis, there are no perfection kan? So, dalam dunia ni mana ada perfection? So, always have a bias, ada error. So kita dalam statistik kita nak minimumkan error tu. Kita nak minimumkan error. So that's why kita set error equal to 5%. So maksudnya daripada result yang kita produce nanti 5% saja yang error, yang tak betul. 95% sepatutnya betul. Itulah dia punya ni. So then kita mesti identify the test statistics. Test statistics kita akan menggunakan Z-test and T-test. Right? Z-test and T-test. So now, in order to use Z-test and T-test, let's say letak kat bawah senang, nanti saya nak bagi dekat you slide ni kan. Right. Sekejap. Statistical test. Right. So we have two type of tests, either Z-test or T-test. So to use Z-test or T-test, kita akan base kepada sample size. If sample size is more than 30, more than or equal to 30, sample size less than or equal to 30. Oh sorry, this one before we go to that one. So variance is known. Ataupun kita kata population variance is known. Population variance unknown. The condition this one lah. Kalau kita tahu the population variance, straight away kita akan pakai Z-test. Z-test, Z equal to X bar minus mu divided by sigma over square root of n. This is a Z-test. So we can use either n is less than 30 or n is more than or equal to 30. So condition dia mana-mana pun boleh. So kalau population variance is unknown, kita akan tengok n less than 30, n more than or equal to 30, the sample size. If n less than 30, we use T statistic, X bar minus mu divided by S over square root of n. If n is more than 30, we can use Z equal to X bar minus mu divided by sigma over square root of n. Okay, boleh? You screenshot this one. This one is very important. Okay. So next, once you already identify the statistical test, so we need to determine the decision rule. Decision rule is based on the hypothesis testing, either one-tail test. So this is one-tail test, or this one, right? Either to the left or to the right. So this is we call one-tail test, or another one is two-tail test. So sebelah kanan dan kiri. So this is what we call two-tail test. Right? So next, we already identified the decision rule. Then we apply the decision rule and draw the conclusion. Right? So this is a basic or fundamental hypothesis testing. So now kita akan tengok one by one. One sample hypothesis testing. Right, kita akan ada banyak lah. Nanti I think dalam setengah jam ni mungkin tak banyak kan I akan bagi. So next week I akan postkan video-video yang lain untuk you understand, right, the next step. So kita tengok muka surat. Muka surat. You ada buku semua kan? Buku is very important Kalau tak ada buku yang susah nak buat susah nak faham test number 2 nanti, susah nak faham. Muka surat 80. Muka surat 80. One sample hypothesis testing. Right. So one sample hypothesis testing, right, means that kalau kita tengok dalam buku tu, dia kata kat sini, first is formulate the hypothesis test by stating null and alternative hypothesis. Formulate the null and hypothesis testing, hypothesis in which null hypothesis, right, describe an existing theory relating to the population parameter. And alternative hypothesis is the complement of null hypothesis. Using the sample data, we draw conclusion on the decision rule, either reject null hypothesis or fail to reject null hypothesis. If reject null hypothesis, the sample data provides sufficient evidence to support null hypothesis, alternative hypothesis. If fail to reject null hypothesis, the sample data does not support the alternative hypothesis. So, maybe you cannot see the clear picture yet. So, now kita tengok this one dulu. So, the null hypothesis for one tail test, right? So, sama ada di sebelah kanan ataupun di sebelah kiri. Dia satu region saja. Region at alpha level. This is alpha. This is the rejection area. Maksudnya the type 1 error. Right, reserve the error lah. So we want our result to be on accepted region. Maksudnya the decision is correct. So this is example of null hypothesis, right? One tail hypothesis. So now first one, kita tengok null hypothesis mu is equal to mu naught. Mu naught is any number lah. Any number. So, an alternative hypothesis can be mu is more than mu naught. Number 2, mu is equal to mu naught. Mu is less than mu naught. This is, kalau di sebelah, this one, number 1 so the distribution would be, the rejection area will be on the right. Lebih besar, nampak tak? Dia lebih besar. So, null hypothesis, mu equal to mu naught. Alternative hypothesis, mu is more than mu naught. Right? For number 2, dia distribution dia di sebelah kiri. This one tak explain dalam buku dan buku ada banyak kesalahan sikit. So this one, null hypothesis, mu equal to mu naught. Alternative hypothesis, mu is less than mu naught. So kalau dia less than, dia sebelah kiri lah. And number 3, this is where the buku ni buat salah. So I think orang yang buat buku ni bukan daripada statistik background. So, null hypothesis, dia tak boleh ada less than or more than. Dia mesti sama dengan. Dia tak sama. So, this one, dia mesti sama dengan mu naught. Null hypothesis. Dia tak boleh less than or less more than. So, you need to remember that one. This is, you can buat correction sikit lah. Right? So, number 3 and 4 sebenarnya sama kat atas. And two-tail test, when we have null hypothesis equal to naught, mu is equal to mu naught, and alternative hypothesis, mu is not equal to mu naught. So, kita tak tahu sama di sebelah kanan atau di sebelah kiri. So, kita akan draw dua-dua region, on the right and left. So, notice that this one is alpha, this is also alpha. And for two-tail test, this one is alpha divided by 2. They are sharing 2 region lah. Boleh Ada soalan tak setakat ni? So nanti kita tengok detail dia. First, second step is we select a significant level. Right? Significant level. Understand the potential error hypothesis testing. Null hypothesis is true. Alternative hypothesis fail to reject. Tapi this one, kalau you nak baca nanti susah nak faham. Nanti you boleh baca. This one, metric, confusion metric tadi ada cerita tadi. Okay, now. Then, step number 3, we need to select the statistical test. Right? Hypothesis testing, when population variance is known, kita akan menggunakan Z distribution. When population variance is unknown, kita tengok the sample size. If the sample size less than 30, use T distribution. If the sample size more than 30, use Z distribution balik lah. I dah bagi dekat you the map dekat sini kan. So you should remember this one. Luckily you don't have any final exam kan. It's good lah. And then step number 4, determine decision rule, and last is make a conclusion based on the problem. So this is the Excel function. Boleh tengok dalam muka surat berapa? Muka surat ni semua boleh baca dalam buku dalam buku muka surat 82, right? Semua ni I ambil dalam muka surat 82, benda yang sama, right? So now let's look at example number 1. So this one I nak tunjuk dekat you how we process apa yang dicerita dalam page 80 hingga 81, right? So a fast food restaurant claim that customer order will serve within 8 minutes. So a fast food restaurant claim that customer order dia akan serve dalam masa 8 minit. Sama macam McDonald dalam masa 3 minit dia akan serve kan. Dia kata. So the manager of restaurant receive some complaint on the waiting time. So ramai orang complain, manager collect sample of 50 customers waiting time in minutes. So result data dalam fast food restaurant customer waiting time. So at 5% level of significance, so this is our alpha, right? This is our alpha. Using a critical value approach and p-value approach for the hypothesis testing, is there, dia kata sini, dia nak tahu, is there any evidence that the sample mean waiting time to place an order support the claim made by the restaurant? Kita nak test tengok, waiting time yang dia collect data tu, betul tak? Customer ni waiting time within 8 minit dah serve dah dia punya makanan. So kita tengok dia punya data. Fast food order restaurant. So, kita ada customer 1 until customer 50. You dah buka kan file ni? Cuba buka file ni. Hello? Right.
Ya doktor.
So,
ini yang fast food.
Ya, fast food. So dekat sini, kita nampak dekat sini dia ada customer and time. Customer 1 8 minit, customer 2 7 minit, customer 3 9 minit. So dia kita nak tengok betul tak claim dia. So first step, where is my pen? I nak pen color hitam. Okay. So first step, hypothesis. Oh, tebalnya. Hypothesis testing, right? Hypothesis testing. So first step, kita nak create the hypothesis statement. Claim by manager kata fast food will serve less than 8 minutes, right? So the null hypothesis would be mu is equal to 8 minutes. Alternative hypothesis, mu is less than 8 minutes. Right? Okay? So ini our test. Dalam buku dia salah kan? Kan I cakap dekat tadi, null hypothesis tak boleh ada less than, mesti ada more than. So then we select the significant value. Significant value, our alpha is equal to 0.05. Tengok balik formula dia punya data, 0.05 as level of significant. Ataupun kita kata level significant value lah, benda yang sama. Next, kita akan tengok test statistic. Test statistics. So now, before we go to the test statistics, kita akan tengok. Oops. Kita akan calculate sikit, right? Kita akan calculate sikit, which is our alpha, which is 0.05, right? And our n, kita nak calculate statistik kan, kita tengok n kita ada berapa orang? 50 kan? Remember tadi I cakap dekat you the test statistik yang kita akan pilih ni, when the population variance is known, use that statistics. When the population variance is unknown, tengok balik dia punya sample size. When the sample size is less than 30, use T. When the sample size is more than 30, use Z distribution. Right? So now, our N is count A from this one to this one. So we have 50. So since the population variance is unknown, dalam soalan ni kita tak tahu population variance dia. Right? Dia pun tak bagi tahu what is the population variance. Right? So since the population variance is unknown, we look into the sample size. So the sample size is more than 30. So when the sample size is more than 30, so we will use Z distribution. X bar minus mu divided by S divided by square root of N. Tadi saya tulis betul tak? Sekejap tengok balik. So this one bukan sigma. This one I tukar balik. This one is not sigma. This one should be S lah. Sebab dia population variance is unknown kan. Population variance is sigma square kan. So population variance is unknown, kita akan pakai S lah. Right? So S. So now, dalam test statistik ni kita perlukan apa? Kita perlukan X bar, kita perlukan mu, kita perlukan S, kita perlukan N. Right? This is the parameter yang we want. So we already have the mu, which is equal to 8. And then we need to calculate the average. So kita letak mu dulu lah. Kita dah tahu mu kan. So, insert symbol, cari mu. Where is mu? Yeah, this is mu. Okay, mu equal to 8. Right? And then kita nak cari average. Average ataupun kita letak simbol kat sini, X bar. Kita lihat X bar. X bar lah, X bar. Kita cari X bar kat sini. Letak simbol X bar. Oh, tak keluar. Tak apalah, average waiting time lah, waiting time. So we know average waiting time is X bar. So kita ambil average sampai habis, tutup kurungan. Kita dapat average is 8.02. Sama tak dengan apa yang dibuat tu? 8.02. Page number 84, right? So we know the average is 8.02, and then next kita kena ada apa kat sini? S kan? S is a standard deviation. Standard deviation. Right. So saya besarkan sikit, nanti dia tak sama. Right. Okay nampak standard deviation is SPDV. Kita study tadi kan. Kita tahu the formula dia. Sampai bawah kita akan dapat standard deviation is 1.34756. So ini tak payahlah panjang-panjang kan. Kita boleh reducekan kepada 2 decimal point. Cukuplah 1.35. And then square root of n. So kita ada square root of n kat sini kan. So n kat sini. So kita ambil SQRT square root. SQRT square root of n, right? SQRT. Our N dekat sini 50 kan. Alright. Tu tutup. So kita dapat 7.07. So kita ambil 2 decimal point sudah cukup. Next, apa lagi kita perlukan? Apa lagi kita perlukan? Kita perlukan the value sini kan? Berapa? T-test. T-test. Sorry, this is a Z-test. Z-test. So, this one, formula dia x bar minus mu. So, equal to x bar, this is x bar, minus mu, which is 8, divide by S, which is, ini kita tutup kurungan, S, standard deviation, divide by square root of N. Right, tutup kurungan, tutup kurungan. So, kita akan dapat 0.149. Actually, benda yang sama lah dengan buku, tapi buku salah tulis. Right, so kita ambil. Untuk test statistik, kita boleh ambil 4 decimal point. Z statistics. So, now kita masukkan the value kat sini. Right, so this one should be 0.1049. Okay. Right, so next, what we need to do is, we need to create a decision rule. Decision rule. Right, decision rule, kita kena draw dulu lah. Kita punya, bukan decision rule, sebelum decision rule is critical region. Oops. Critical region. Our critical region is on which area? Left or right? Kita tengok kepada null alternative hypothesis, which is on the left. So kita ambil critical region kita on the left. Right? So this area is 0.05, which is alpha. Next. Next, kita nak tahu dekat sini, kita dah garisan kat sini. So this garis is apa? Apa benda value? Apa value dekat sini? Then kita nak calculate critical region ataupun critical value. Critical value. So this is a critical value, right? Critical line ni lah, right? So this is what we call rejection area. This is what we call acceptance area, right? Acceptance area. So next, we will find the critical decision rule. So sebelum kita nak cari decision rule, kita nak cari dia punya value or critical value lah. So critical value, kita letak kat sini. Critical value. So now, nak cari critical value, kita tengok dekat dekat formula ni. Formula Excel ni. So dia katakan find the critical Z value. So dekat sini find the critical Z value. Lagi kita ada T value, T value, T value. So kita tak perlu T value lah. Ada lagi tak? So kita akan menggunakan normal S inverse 1 minus alpha. So normal inverse 1 minus alpha. So kita letak sini equal NORM dot S dot inverse 1 minus alpha. Our alpha is 0.05. So we will get 1.64. So since they are on the left hand side, right? So this one should be negative 1.64. Negative 1.644, right? So now, decision rule, if the calculated, Z calculated yang mana? Z calculated yang ini, right? Z calculated less than negative 1.644, then null hypothesis is rejected. So if Z calculated is more than negative 1.644, then null hypothesis is accepted. So next, kita dah ada decision rule. Our decision, since Z calculated is equal to 0.1049, is more than Z critical region, negative 1.644, then null hypothesis is accepted. Ataupun paling senang nak faham, if Z calculated falls inside rejection area, null hypothesis is rejected. Right? So since, kita punya decision dekat sini, since Z calculated falls inside acceptance area, nampak tak this one? This one should be 0 kan? 0.10 ni dia sepatutnya ada dekat sini lah. This is area Z calculated kan? So since Z calculated is fall inside accepted area, null hypothesis is accepted. So then we need to make a conclusion. So since null hypothesis is accepted, conclusion dia, we accept null hypothesis. So we can say that the waiting time, the customer will be served within 8 minutes. Right? Itu je. Okay? Boleh? Boleh faham? So, I think masa pun dah tercukup dah 10.30 dah. Lepas ni ada kelas lain pula. Right? So, untuk test-test yang lain dalam buku ni, contoh macam example number 5.2, one sample proportion, two sample hypothesis testing, one sample t-test, independent sample t-test, one way ANOVA, semuanya akan masukkan dalam video, right? So you boleh tengok video. Kita cuti lama juga, kita rehat nanti sebulan juga. So kita akan masukkan video. Make sure you understand, and if you have any problem, you can always ask me again and again, right? Okay, I think that's all. Thank you very much. Ada soalan tak?
Yang tadi tu nanti ingatkan doktor hantar slide tu. Ingatkan?
Saya akan slide. Tapi remind me lah, takut lupa kan. Boleh ya? Thank you. Okay, I think that's all. Thank you very much. Assalamualaikum.
Assalamualaikum.